Here's the thing about the planet Venus. On the one hand, this is the most hostile environment that exists in our solar system. Venus is a flaming hot acid-soaked high-pressure volcanic wasteland. On the other hand, Venus is the most Earth-like planet in our celestial neighborhood, our closest sibling if you may. In fact, Venus is more than likely the only Earth-like planet that we will ever be able to visit with a spacecraft. That makes the study of Venus one of the most important scientific endeavors we can take on. By understanding the differences and the similarities between Earth and Venus, we get closer than ever to understanding the nature of our own existence. And that's why for the first time in 40 years NASA will be going to the planet Venus on a mission to answer some of the most fascinating questions of the universe. The mystery of Venus is how it can be so fundamentally similar to the Earth and yet so catastrophically different. Venus is more or less the same size and mass as the Earth, so it has a nearly identical gravity. Venus comes closer to the Earth than any other planet on its orbital path, and yet the surface of Venus is sitting at a hellish 900 degrees Fahrenheit, around the same temperature as the inside of a wood-fired pizza oven. All of that heat is held in by a massively thick atmosphere that generates 93 times the atmospheric pressure of Earth, or around 1,300 psi. It's the equivalent of being underneath 3,000 feet of water. At that pressure, the carbon dioxide-filled air on Venus is technically no longer a gas, it becomes a supercritical fluid, which is not quite the same as liquid, it's something in between. So to move around on Venus you'd have to push against the fluid atmosphere. You could even try to swim through the air if you hadn't already been crushed and incinerated, of course. And if that weren't enough, the thick orange clouds that drape over the entire planet are made of sulfuric acid and rage with 200 miles per hour winds, lightning storms and acid rain. This is the reason why we haven't been sending probes and landers to Venus since the 80s. Mars just turned out to be a much more hospitable place for interplanetary exploration, and Mars has been very good to us. It's been a fantastic testing ground for all kinds of new technology, from communications to orbiters, landers, rovers, and even helicopters. Mars is also kinda boring, sorry Elon, but it's mostly just a dead frozen rock covered in barren desert. Venus may be well past its prime, but the planet still has life left in it. We think there could still be active volcanoes down there, maybe some level of plate tectonics, or even bacterial life floating around in the atmosphere. It's just a deeply fascinating place that is so close and so familiar yet almost completely unknown. Da Vinci Plus. This is why NASA has approved 1 and possibly even 2 missions that will fly to Venus as early as 2029. These will be the first NASA spacecraft to visit the planet since the Magellan orbiter was launched in 1989. Even for its time, Magellan wasn't a great spacecraft, it was mostly just old spare parts from Voyager and Galileo all hacked together, but the mission was able to image the entire surface of Venus only with a fairly low resolution of 1 pixel per 100 meters of surface. Da Vinci Plus is very exciting because this will be a combination orbiter and lander. The Plus is a reference to design improvements that have been made since the original Da Vinci mission was crafted back in 2015. Obviously that's a reference to the famous Renaissance artist Leonardo, but Da Vinci also stands for Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging. The spacecraft is going to perform 2 flybys of the planet to analyze the upper atmosphere and study the cloud tops in the ultraviolet and near-infrared light spectrums, tracking cloud patterns over time and trying to figure out what chemicals up there are absorbing ultraviolet light. As the spacecraft comes around the night side of the planet, it will be looking for sources of heat emanating through the dark, which should help us to get a better idea of the surface composition. Then on the third approach, about 2 days away from Venus, Da Vinci Plus will release its atmospheric descent probe. This contains a 1-meter diameter titanium pressure vessel that is roughly spherical in shape, and that device will be making the hellish journey all the way down to the surface of Venus. Around 40 miles above the ground, the probe will jettison its heat shield and begin ingesting atmospheric gas that will be sampled and analyzed for detailed measurements of chemistry composition and structure. It's going to take about an hour for the probe to descend the thick atmosphere, and as it falls the equipment will be measuring everything from wind speed to air pressure and temperature. As it breaks through the cloud barrier around 100,000 feet above the surface, the probe will begin taking hundreds of images. This is going to provide us with high-resolution mapping of the Alpha Regio Mounds, which is a region about double the size of Texas. Particularly, the imaging sensors will be looking for any physical sign that water ever flowed on Venus. the probe is going to impact the surface at around 25 miles per hour, at which point it may continue to operate for as long as 18 minutes under ideal circumstances, but it isn't necessary to the mission for the probe to continue functioning on the surface. That's just gravy if it does happen. Earth technology doesn't have a very good track record of surviving on the surface of Venus. Back when we first started sending probes in the 1960s, scientists really had no idea just how hostile the environment would be. There were legitimate researchers who fully believed that there would be tropical rainforests and maybe even dinosaurs on Venus. The first probe that attempted to parachute down through the atmosphere was the Soviet Venera 4. It transmitted data for just a few minutes before terminating the signal in mid-air. It was probably crushed like a beer can before reaching the surface. After that lesson, the Russians sent Venera 7 to try landing again. The probe was built like a tank to try and survive the conditions, but the parachute wasn't sturdy enough, so it dropped like a rock and smashed into the ground. Again, the probe was able to transmit some data, but not nearly as much as they hoped for. We got a bit better after that. From 1975 to 1981, a handful of probe missions were able to land on the surface and transmit small amounts of data before they were killed off by the environment. We got surface samples, photographs, and even sound recordings from the planet Venus over a 10-year period. The final Russian mission dropped balloon probes into the clouds of Venus that spent about one day being carried over 11,000 kilometers by the wind. That was in 1984. Obviously, the change in technology over 45 years is going to deliver a vastly more detailed look at the surface of Venus and the composition of its atmosphere. Scientists are actively working more robust electronics that use silicon carbide in place of regular silicon. It will stand up to the heat, but also makes designing high-precision chips and motherboards much more difficult. Engineers are also working on thermal batteries that will resist overheating. The idea is to use an electrolyte material that is solid at room temperature but will melt into a liquid when exposed to the 900-degree heat and activate the battery. The designers of the probe also need to be careful about using materials that will resist the acidic chemical environment. That means reactive metals like copper are just not going to work. Veritas. The second Venus mission, named Veritas or Venus Emissivity Radio Science in Star Topography and Spectroscopy, is actually in a little bit of trouble right now, so it's unsure when or if this one will ever fly. When NASA wrote up their 2024 budget proposal to Congress, they cut funding for Veritas down to a level that essentially puts the project into a deep freeze for the indefinite future. Which is a shame, because the concept for Veritas was really solid. It was originally scheduled to launch as early as 2027 and would have picked up right where Magellan left off, mapping the entire surface of Venus, only this time with a resolution up to 15 meters per pixel. And NASA scientists were kind of hoping to use that high-res map to help them fine-tune the deployment of the Da Vinci probe, but that's all become a lot more complicated. Conclusion. Venus is worth it though, because it has so many questions that still need to be answered. I mean, we don't even know what the rocks there are made of or what the interior of the planet looks like, and what we find on Venus could unlock secrets about the deep history of our own planet. We know that the Earth maintained a habitable environment, but nearly identical Venus did not. Why is that? Was Venus always hot? Was it just that little bit too close to the sun so that it never cooled down, or was it temperate at some time in the past? Was there water or even life? And if that's true, then what went wrong? If Venus has so many volcanoes, then why doesn't it have tectonic plates floating on the liquid mantle like Earth, or does it? We know that Venus doesn't have a magnetic field right now like the Earth, but did it have one before? And if it did, then where did it go? And if there is no magnetic shield repelling the solar wind, then what is keeping the atmosphere so tightly attached to Venus, and where do all of those clouds even come from? If they were created by the extreme volcanic activity like we believe, then they should have dissipated as the volcanoes died out hundreds of millions of years ago. So how do those clouds stick around, and what is seemingly replenishing them? And beyond that, what phenomenon is driving the constant hurricane force wind in the upper atmosphere? I don't know about you, but I feel like this is all stuff that we should probably know, and we should learn it sooner rather than later. The James Webb Telescope is really cool and all up there looking for exoplanets in distant solar systems, but we already have a deeply fascinating, mysteriously active alien world literally right here next to us, so we should go there.